Monsoons are like a heat engine, which collects, concentrates, stores the sun's energy of South Indian Ocean and transports it to the Great Northern Plains and release it over the parched landscape. Monsoons are experienced in the tropical area roughly between 20 degrees N and 20 degrees S. To understand the mechanism of monsoons, the following facts are important. The differential heating and cooling of land and water. It creates low pressure on the land mass of India while the seas around experience comparatively high pressure. This strengthens the monsoon through the low pressure system created due to heating of Indian subcontinent, also known as ITRCZ, and the whole system acts as a magnet and attracts moisture-laden winds. Over the north, the process of condensation results into releasing of latent heat, thereby sustaining high temperature in northern region and hence low pressure region, i.e. conditions of monsoon through perpetuate themselves. The shift of the position of intertropical convergence zone ITRCZ, also called monsoon through or doldrums, as sun moves northwards. The intertropical convergence zone ITRCZ or thermal equator is a broad through of low pressure in equatorial latitudes. It always remains on the north of the equator due to effect of land mass. This is where the northeast and the southeast trade winds converge, and this is a low pressure zone. This convergence zone lies more or less parallel to the equator but moves north or south with the apparent movement of the sun. At the time of monsoons, it shifts towards north, toward India, and hence attracts moisture-laden winds. According to meteorologists, monsoon is the result of the shift of the ITRCZ under the influence of the vertical sun towards Tropic of Cancer. The ITCZ, being the zone of lowest pressure in the tropical region, is the target destination for the trade winds of both the hemispheres. Consequently, with ITRCZ at the Tropic of Cancer over Indian Peninsula, the southeast trade winds of the southern hemisphere passed across the equator to reach the ITCZ. However, due to Coriolis effect, these southeast trade winds are deflected eastward in the northern hemisphere, transforming into southwest trades. These pick up the moisture while traveling from sea to land and cause orographic rain once they hit the highlands of the Indian Peninsula. This results in the southwest monsoon. The presence of the high pressure area east of Madagascar, approximately at 20 degrees S over the Indian Ocean. The intensity and position of this high pressure area affects the Indian monsoon. The Tibetan plateau gets intensely heated and a low pressure is created over plateau. It results in strong vertical air currents and the formation of low pressure over the plateau at about 9 kilometers above sea level. The movement of the westerly jet stream to the north of the Himalayas and the presence of the tropical easterly jet stream over the Indian Peninsula during summer. It is also believed that the burst of monsoon succeeds the shift of this jet from south of Himalayas to north of Himalayas, as their shifting allows inflow of warm and wet winds to the subcontinent. Effect of ENSO on Indian MOS and SOON. Apart from this, it has also been noticed that changes in the pressure conditions over the southern oceans also affect monsoons. El Niño is actually a warm current that flows off the coast of Peru. La Nina is its opposite and is a cold current which flows along the same coast, but in opposite direction. While El Niño is an oceanic phenomenon, so is a weather/atmospheric phenomenon. Since ocean currents are closely linked with the atmosphere, their circulations and pressure also, this change of El Niño to La Nina also affects the pressure conditions. The standard measure is taken as the difference of pressure of Tahiti, an island in Pacific Ocean marked as X, and Temps La Nino/La Nina and Darwin in Australia Z, which is closer to India. Normal situation. Normally, when the tropical eastern Pacific Ocean near Tahiti sea fig marked as X experiences high pressure, the tropical eastern Indian Ocean sea figure, marked as white, and western Pacific Ocean near Darwin Z experiences low pressure. It creates a condition of negative pressure difference. Darwin/Indian Ocean and Tahiti equals Z/X, Y. Abnormal situation, but in certain years, there is a reversal in the pressure conditions and the eastern Pacific X has lower pressure in comparison to the eastern Indian Ocean Y or western Pacific Ocean Z. It creates a condition of positive pressure difference. Darwin/Indian Ocean and Tahiti equals Z/X, Y. This periodic change in pressure conditions is known as the Southern Oscillation or SO. Since El Niño/La Nina and SO are interlinked, they together are referred as ENSO. The effect of ENSO on India. Usually, if the pressure differences were negative, It would mean below average and late monsoons. I.E. During El Niño conditions or normal conditions, weak monsoon is observed, though not always. And when La Niña conditions exist, though not always. Onset of a monsoon. A monsoon, unlike the trade winds, are not steady winds but are pulsating in nature, affected by different atmospheric conditions encountered by it on its way over the warm tropical seas. The duration of a monsoon is between 120 days from early June to mid-September. Burst of monsoon. Around the time of its arrival, the normal rainfall increases suddenly and continues constantly for several days. This is known as the burst of a monsoon, and can be distinguished from the pre-monsoon showers. Pre-monsoon showers or mango showers. Mango showers are the pre-monsoon showers in the Indian states of Karnataka, Kerala, Konkan and Goa that help in the ripening of mangoes. Also known as April rains or summer showers, they are the result of thunderstorms over the Bay of Bengal. These summer rains normally come in the second half of the month of April. The showers prevent the mangoes from dropping prematurely from trees and are crucial for the mango cultivators of South India. Bifurcation of monsoon winds. A monsoon arrives at the southern tip of the Indian peninsula generally by the first week of June. Subsequently, it proceeds into two, the Arabian Sea branch and the Bay of Bengal branch. The Arabian Sea branch further split into three branches. 8. Sahyadri branch. Its one branch is obstructed by the Western Ghats. These winds climb the slopes of the Western Ghats from 9001 to 00 m. Soon, they become cool, and as a result, the windward side of the Sahyadri's Western Ghats in Maharashtra and Western Coastal Plain receive very heavy rainfall ranging between 250 centimeters and 400 centimeters. This is the reason Mumbai gets high rainfall 190 centimeters and the regions like Kandala even more 450 centimeters. Due to orographic rains and Pune doesn't receive much as it falls on leeward side of Ghats. Rain shadow area of Western Ghats. After crossing the Western Ghats, these winds descend and get heated up. This reduces humidity in the winds. As a result, these winds cause little rainfall east of the Western Ghats. This region of low rainfall is known as the rain shadow area. B. Another branch of the Arabian Sea monsoon strikes the coast north of Mumbai. Moving along the Narmada and Yaki river valleys, these winds cause rainfall in extensive areas of central India. But these don't cause much rains as of Mumbai branches there are no orographic rains, and this is the reason that Nagpur receives comparatively lesser rainfall while Mumbai receives 190 centimeters. Nagpur receives 60 centimeters. The show the Nagpur Plateau gets just 15 centimeters rainfall from this part of the branch, as it has lesser moisture by the time it reaches here. Thereafter, they enter the Ganga Plains and mingle with the Bay of Bengal branch. C. Saurashtra branch. A third branch of this monsoon wind strikes the Saurashtra Peninsula and the Kachh. It then passes over West Rajasthan and along the Aravallis, causing only a scanty rainfall, but still some orographic effect is there which leads to relatively high rainfall in Mount Abiyu. However, surrounding plains are relatively drier. In Punjab and Haryana, the two join the Bay of Bengal branch. These branches, reinforced by each other, cause rains in the western Himalayas. The Bay of Bengal branch strikes the coast of Myanmar and part of southeast Bangladesh. But the Arakan hills along the coast of Myanmar deflect a big portion of this branch towards the Indian subcontinent. A monsoon, therefore, enters West Bengal and Bangladesh from south and southeast instead of from the southwesterly direction. From here, this branch splits into two under the influence of the Himalayas, and the thermal load is northwest India. 8. Northern Plains branch. Its one branch moves westward due to obstruction by Himalayas and moves along the Bengal Plains, reaching as far as the Punjab Plains. B. Brahmaputra Valley branch. The other branch moves up the Brahmaputra Valley in the north and the northeast, causing widespread rains. Its sub-branch strikes the Garo and Khasi hills of Meghalaya. Morph and Rum, located on the crest of Khasi Hills, receive the highest average annual rainfall in the world, as it is located perpendicular to the direction of monsoons, and orographic rains are caused in abundance. Delhi generally receives a monsoon showers from the Bay of Bengal branch by the end of June. Tentative date is 29th of June. By the first week of July, western Uttar Pradesh, Punjab, Haryana and eastern Rajasthan experience a monsoon. By mid-July, a monsoon reaches Himachal Pradesh and the rest of the country. The Arabian Sea and the Bay of Bengal branches of a monsoon merge over the northwestern part of the Ganga Plains. Arabian Sea branch is stronger than Bay of Bengal branch due to following reasons. Arabian Sea branch is larger than Bay of Bengal branch, while Arabian Sea branch enters into Indian Peninsula in its entirety. The Bay of Bengal branch enters partially with its parts also moving to other areas like Thailand, Myanmar, etc. Break in monsoon shipping of through towards Himalayas. Another phenomenon associated with a monsoon is its tendency to have breaks in rainfall. Thus, it has wet and dry spells. In other words, a monsoon rains take place only for a few days at a time. They are interspersed with rainless intervals. These breaks in monsoon are related to the movement of the low pressure zone or a monsoon through. It is believed to be due to collapse of Tibetan High and the through shifts towards Himalayas, and rainfall occurs in Himalayan region, leaving the plains dry and hence causing the break. For various reasons, a monsoon through and its axis keep on moving northward or southward, which determines the spatial distribution of rainfall. When the axis of a monsoon through lies over the plains, rainfall is good in these parts. On the other hand, whenever the axis shifts closer to the Himalayas, there are longer dry spells in the plains, and widespread rain occur in the mountainous catchment areas of the Himalayan rivers. These heavy rains bring in their wake devastating floods, causing damage to life and property in the plains. The frequency and intensity of tropical depressions, too, determine the amount and duration of monsoon rains. These depressions form at the head of the Bay of Bengal and cross over to the mainland. The depressions follow the axis of a monsoon through a low pressure. A monsoon is known for its uncertainties. The alternation of dry and wet spells varies in intensity, frequency, and duration. While it causes heavy floods in one part, it may be responsible for droughts in the other. It is often irregular in its arrival and its retreat. Hence, it sometimes disturbs the farming schedule of millions of farmers all over the country. Withdrawal or the retreat of a monsoon. By the end of September, the southwest monsoon becomes weak as the low pressure through of the Ganga Plain starts moving southward in response to the southward march of the sun. It is a more gradual process. The withdrawal of a monsoon begins in northwestern states of India by early September. By mid-October, it withdraws completely from the northern half of the peninsula. The withdrawal from the southern half of the peninsula is fairly rapid. By early December, a monsoon has withdrawn from the rest of the country. October heat. The retreating southwest monsoon season is marked by clear skies and rise in temperature. The land is still moist. Owing to the conditions of high temperature and humidity, the weather becomes rather oppressive. This is commonly known as the October heat. The islands receive the very first monsoon showers, progressively from south to north, from the last week of April to the first week of May. The withdrawal takes place progressively from north to south from the first week of December to the first week of January. By this time, the rest of the country is already under the influence of the winter monsoon. Winter monsoons do not cause rainfall as they move from land to the sea. It is because, firstly, they have little humidity characteristics of monsoonal rainfall that is mainly orographic in nature. Western Ghats, Himalayas plays an important role. At the same time, Aral Valley fails to play a role because it runs parallel to the advancing monsoons. It occurs in torrents. Only a few months cause majority of the rain. It is variable in nature. Rainfall received from the southwest monsoons is seasonal in character. Monsoonal rainfall is largely governed by relief or topography. For instance, the windward side of the Western Ghats registered a rainfall of over 250 centimeters. Again, the heavy rainfall in the northeastern states can be attributed to their hill ranges and the eastern Himalayas. A monsoon rainfall has a declining trend with increasing distance from the sea. Kolkata receives 119 centimeters during the southwest monsoon period, Patna 105 centimeters, Allahabad 76 centimeters, and Delhi 56 centimeters. The summer rainfall comes in a heavy downpour, leading to considerable runoff and soil erosion. A monsoon rains occur in wet spells of few days duration at a time. The wet spells are interspersed with rainless interval known as breaks. Monsoons play a pivotal role in the agrarian economy of India because over 3/4 of the total rain in the country is received during the southwest monsoon season. So even a weak monsoon means a gamble with crops as farmers depend on it heavily and other irrigation systems are not well developed. With still more than 50% population depending upon agriculture, it has great economic impact. Its spatial distribution is also uneven, which ranges from 12 centimeters to more than 250 centimeters. Monsoons and the economic life in India. Monsoon is that axis around which revolves the entire agricultural cycle of India. It is because about 64% people of India depend on agriculture for their livelihood, and agriculture itself is based on southwest monsoon. Except them lies all the parts of the country have temperature above the threshold level to grow the crops or plants throughout the year. Regional variations in monsoon climate help in growing various types of crops. Variability of rainfall brings droughts or floods every year in some parts of the country. Agricultural prosperity of India depends very much on timely and adequately distributed rainfall. If it fails, agriculture is adversely affected, particularly in those regions where means of irrigation are not developed. Sudden monsoon burst creates problem of soil erosion over large areas in India. Tamil Nadu and southwest monsoons. Tamil Nadu coast remains dry during this season. There are two factors responsible for it. The Tamil Nadu coast is situated parallel to the Bay of Bengal branch of southwest monsoon. It lies in the rain shadow area of the Arabian Sea branch of the southwest monsoon. Tamil Nadu, on the other hand, gets rain from the retreating monsoon or the northeast monsoon as it picks moisture from Bay of Bengal. Thar Desert and monsoon. The reason that Thar has formed in west of India is probably explained by lack of rainfall. The lack of rainfall is mainly due to the unique position of the desert with respect to the Aravalli Range. The desert lies in the rain shadow area of the Bay of Bengal arm of the southwest monsoon. The parallel nature of the range to the Arabian Sea arm also means that the desert does not receive much rainfall.